Right. Hello, my name is Alicia Clark, and I am in Group 1. This is my combined spectral problem. I'm going to walk you through my process of how I got to my end compound or molecule. So we started out with C6H12O2. So we know we have two oxygens in this one. So that's when we would start to think about which one of our functional groups has two oxygens, such as some of the things with like carbonyls, like we have this large spike with a carbonyl here. So we would think about our aldehydes, we would think about carboxylic acids, we would think about esters, because those have two oxygens present. I have marked at 172 parts per million. I have my carbonyl marked because carbonyls are super duper obvious. They are also super duper obvious in our IR spectroscopy as well. So I have my carbonyl in green over here as well at 1740. I also have at 60 parts per million back to my carbon 13 NMR. I have carbon with some other heteroatom are usually like 50 to 70-ish. So I know that it is an oxygen because that is the only heteroatom that is available to me right now. But I just kind of mark it as X as part of my beginning thought process. I also have three other spikes, and these are between 0 and 40. So I know that these are carbons bonded to other carbons. Down to my IR spectroscopy, I have my carbonyl, which we've already mentioned. I also have my signature carbon to hydrogen sp3 hybridized spike that is here, and we have that little ketone bump from that carbonyl that kind of clues you into, yes, confirming, not necessarily, but kind of confirming that is a carbonyl that we're dealing with here. We do not have that marked like that O loop that is usually present for like our carboxylic acids or alcohols. So I start to look elsewhere for what else could be using that oxygen. And so over here we have this very large spike where our carbon is bonded to an oxygen, because oxygen is super electronegative, it's loud, it likes to make itself known, so it usually causes super big spikes. So I marked that spike there at 1190. For my proton NMR, I'm just gonna zoom in a little bit here. You were generous with giving the hydrogens. So I was just able to zoom in and figure out what my multiplicity was. So I have a triplet here because it's 1, 2, 3 spikes, a triplet. I have another triplet with 3 spikes here. That's 3 hydrogen in that triplet. This multiplicity has 6. It's a multiplet, but I just put 6 just to be sure that this particular hydrogen is bonded to 5 other hydrogens, just to kind of have that number there so I'm aware of it. The 2 hydrogens next to it is also a triplet, and then those 2 hydrogens there down on the end is a quartet because it has 4 little spikes or blips. I went ahead and transferred everything over to my chart here that is present. My molecular formula, we'll get to that when we get down to what I got as my proposed structure. My degrees of unsaturation are 1 because I have 6 times 2. Let's zoom out a little bit. So I have 6 carbons, right? So my ideal would be 6 times 2 is 12. Plus 2 equals 14, and that is my ideal amount of carbons. What I actually have for my actual carbons or hydrogens, that's my ideal amount of hydrogens. For my actual amount of hydrogens, I have 12. So 14 minus 12 is 2. Divided by 2, I have 1 degree of unsaturation, and that is accounted for down here. For my carbonyl there, it's also accounted for here. I've confirmed I have a carbonyl with that double bond, and I have a carbonyl here. So that degree of unsaturation confirmed by a double bond or ring is already there and confirmed. So I don't really have to think about that too much anymore. I just ordered my frequencies, highest to lowest, the furthest down field to the furthest up field is how I have ordered them here. Just to confirm the things that I have found with my proposed structure. I have, I'm marking a little bit. So my proposed structure is ethyl butanoate. Reason I proposed this structure is because it has that carbonyl that is present right here. I also went through and I confirmed my hydrogens because I like to check things by confirming my placement of my hydrogens. I did play around with this a little bit off screen to do trial and error, but this is what I came up with. So I confirmed that this hydrogen, the CH3 on the end here, is a triplet because we have 2 hydrogens here. N plus 1 is 3. That's my triplet. We have a quartet for these hydrogens here. I'll mark that a little bit. It's okay. I have 3 hydrogens. N plus 1 is 4. That's a quartet. Over here, we have a triplet because of the hydrogens here. There are no hydrogens here because this carbon has 4 bonds already. So that would be a triplet. For these hydrogens here, it is a multiplet because we have 5, which would be N plus 1 is 6, and that's that 6 that I mentioned earlier, just to keep in mind of how many hydrogens I will be on the lookout for on my final structure. So that's my multiplet, and then here on the end, this CH3 here has 3 hydrogens, and it only has these 2 hydrogens next to it, and that is a triplet. So I have confirmed all of my multiplicities. I have ordered them based on the chemical shift. So I put my furthest from my carbonyl and my oxygen because it has less shielding. I put it all the way over here. And the other one, I put that on the end. CH3s are easier to put on the end because that's all there is. And if it's a triplet, then you know that it's with a CH2 and it's very easy to figure out. And that's how I came up with this structure here where I got the ethyl butanoate. And then my molecular formula is CH3, CH2, CH2, C, O in parentheses, that's my carbonyl there, bond to O, CH2, CH3. All right, thank you.